Greetings, Earthlings. Today we're going to take a quick look at a baud rate generator for a 6402 UART. That's that chip there, which I'm planning to use in a project. And so I need to be able to generate different baud rates. Now that takes as input 16 times the bit rate. So you decide what bit rates you want. And in my case, I want at least 300, 1200, 2400, 9600, 19,200, and I'll take 38,400. I don't need anything higher than that. Other standard rates, 57, 600, 115, 2. Don't need those for what I'm doing. Though, of course, they'd be nice. But they turn out not to be powers of 2 of the other rates, or multiples of powers of 2 of the other rates. So it's a little harder to generate them with this simple circuit that I'm looking at. Okay, so the circuit is very simple. Let's take a look at it here. This is an oscillator in a dip package. This is a 74HC 4060 and a 74 HC151, some dip switches. The data rates I need. Well, on the high end, for 38,400, I need 614,400 hertz. At the low end, 300, I need 16 times 300, or 4,800 hertz. This chip is basically, I don't know if you can see that or if the ground lead is in the way there on the scope. This is basically a bunch of dividers, divide by 2s. And so, as it turns out, if I use a clock of 19.6608 megahertz, then I can get all the rates I need out of this chip. And then I'm using this chip. This is a 1 of 8 selector. I use this chip to select the specific rate I want. So if we take a look on the oscilloscope, and this oscilloscope has a built-in frequency counter, which is right up here. You can see it's operating currently at 4.800 kilohertz, which is what I need for 300 bits per second, 300 baud. That's not as low as it'll go. I can actually go down as low as 2.4 kilohertz, which would be 150 bits per second, which is, I don't think anybody ever uses that anymore. I don't think I'll have a need for it. So that's 300 baud, 4.8 kilohertz. That's 1,200 baud. Wait, what happened to 600? Well, I skipped 600 because nobody uses it for anything. And the other thing is the chip, the divider chip, does not give every possible output. So that's the one I chose to throw away. And that also factored into choosing the clock speed, because I could have used a different clock speed, taken taps off of different outputs and gotten other rates. But this is what worked out well for the rates that I wanted. So that's 1,200. There's 2,400 is 38.4 kilohertz. And then we go to 76.8 kilohertz. That would be 4,800. Next is 153.6, which is 9,600. You can guess what's next. There we go. 307.2, which is 19,200. And the final one is 614.4, and that's 38,400 baud. So that's it, just a simple little circuit I wanted to demonstrate. It'll be showing up in at least one of my projects that I document here. So that's it.